Good evening. Thank you, everybody, for coming. So as I said, I'm technical evangelist in AWS, and I should add that if you are interested in what I do, we are hiring a technical evangelist in Germany. I always love when there is this cloud talks and everybody on stage, one after the other, is saying, we are hiring, we are hiring. So if you were interested, just ping me. We are quite flexible on the location within Germany. So if you need to reach to me after this talk, I am Danilo on Twitter. My GitHub account is Danilo, and guess my email at amazon.com, danilo@amazon.com, so you can reach to me and ask any question. So today, just a few words about me. I started with AWS almost 5 years ago. It was quite a different and smaller company at the time. I started sharing some code that I was writing on GitHub, like shared file system. Then I shared security authentication service using, guess what, serverless technologies. Then I got contacted by Manning, and they asked me to write a book on AWS Lambda. So that's why I brought a copy here, and I will give it out at the end with some random number generator to find someone. So if you have an armchair that is not completely stable, stay here, and then you will get a fix for the armchair at the end. So today I'm really happy here to talk about serverless technology. It's one of my top 3 favorite topics. I love serverless because it's going to change the way we develop application. It will not happen overnight, but I think it's giving an interesting direction to software development. Out of curiosity, the other 2 topics that I really love are IoT, because it's going to change the way we live in the next few years. We are moving in an IoT space from a more industrial space to a more consumer space, close to the way we live in the house and in our homes. And the third topic is machine learning and artificial intelligence, but because I think that that's going to change everything in the next few years. So I think it's something that we also as developers should care about. But let's stick on focus on serverless. So when we talk about serverless, the first main concept that has been introduced when we launched AWS Lambda slightly more than 2 years ago now is the idea of having functions running on the cloud. And you can create your own function. This function gets an input, it can provide an output, and you don't need to think about the servers, the operating system, patching the operating system, or even installing the software framework to run this function. And this function will scale and be kept in high availability for you. And let's just start quick with the first function, just to see how that works. Normally, what is the first program you write in any language? Hello world. But since these are functions, you need to provide an input. I extended the concept to greetings on demand. So you have a function, you give your name, and you get your own customized hello. So let's see how that works. So this is the AWS console. Let's go on Lambda. So you can choose the region. So it's where the data centers that power these services are based. I will use the Frankfurt region. Let's get started. If you start using Lambda, there's lots of blueprints that are here. So for example, if you want to process files that are uploaded to Amazon S3, it's our object storage. You just write S3 here and you get some prototype functions with some code to start with. But now I want to start with a blank function. Then you can choose a trigger. Triggers are very important because it's the way you can link one function to the other. So you can have events that happen in your data, in files that are changed, uploaded by a user, data that is updated on a database, and this can trigger some logic, some functions. For now, I'm not using a trigger. I just want to create a function that I can invoke. And here I can give a name, so let's call it greetings on demand. You can provide a description. Description is a free field that you can use. So if you start to have lots of functions, you can also read the description programmatically using APIs, for example. So you can use the description to store some metadata, sort of very basic service discovery if you want. So it's something that is a hint that I usually give. If you want, you can use the description for some meta content describing your function. Then you can choose your runtime. The runtime is what we provide for the execution of your function. We started with Node.js, and then we added Python, we added Java, Java 8, But actually with Java, you can run anything that runs on a JVM, on the Java JVM 8. So there's lots of people using Scala or Clojure, for example, because with Java you provide a jar file, so anything that runs on the JVM. There's Python. And then you see this Edge Node.js, and we will come back to this Edge Node.js towards the end of the presentation to understand what it is. So for now I'm using Node, and let's give the code for the first function. So I will just cut and paste, because otherwise I'm very slow at typing. So this is a very basic function. Here you see there's the code of the function, and there's some commands before of the function. The commands before of the function are important because they are executed only when we create the container for this function. So with Lambda, what we do, the first time you invoke a function, we will provision very quickly a container where your function can be executed. And then and all the code is executed for the first time. The next execution will only invoke the function. So if you have some slow configuration that you need to add to your code, like loading data or connecting to a database, put that before of the actual function that you want to expose, so that it's executed only sometimes, not for all the invocations. And then I should add that if this container, the throughput of this container grows too much, we will automatically add more containers in parallel. And then if you don't use these containers anymore, because the throughput goes down, we will scale down for you. You don't need to manage that. We do everything for you. So this is the first function. I'm exporting the function. I'm using JavaScript in these examples. If something is not clear or you have any question, just raise your hand and maybe stop me if I don't see your hand, because I'm happy to take questions during the session. So I export this function. It's an anonymous function in JavaScript. And I have 3 parameters. Actually, 2 are the real parameters. Is the event, and the event is the input of the Lambda function. It can be something that comes from other services, like I uploaded a file or I changed something in a database, or can be just the input parameters if I invoke the function directly. Then there is a context. The context object is passed to the functions to understand what is happening around, and we will see a possible use case for managing timeouts. And then this is, of course, not a real parameter. It's only for JavaScript. A classical callback to terminate the function. So you will invoke the callback to terminate the function, and then you can raise an error or pass the result to the callback. Again, here you see that I'm logging, because this is a sample function, so I added more log, as I should do also in production. Since this is a headless environment, so these functions are executed without you having never to log in a server, you can't have access to logs. So built in with AWS Lambda, you get log collection. So everything that is sent to console log, it's by JavaScript, is automatically collected by CloudWatch, our monitoring service, in CloudWatch logs. And then you can access those logs and do different things. You can create metrics or raise alarms based on the content of the logs. And I'm just logging the input event. I'm looking in the event for a name. If the name is in the event, I will use this name. If there is no name in the input event, I will use word. And then I build the greetings as hello plus the value of this name, so hello world or hello and the name that I pass by. I log it for security, and then I call the callback to terminate the function. Null, the first parameter, as in normal JavaScript, is the error. So null means that this is terminating correctly. If you want to raise an error, you put it in the first parameter. And the second one is the output of the function. Most functions have an output, but you can have asynchronous functions that doesn't have function that don't have an output because maybe they change data on some other repository. So you can have a callback with just a null in those cases. So this is a very basic function. I describe it very thoroughly, but it's very simple code. And then you have some configurations for your functions. First are the environmental variables. This is something we added in October, I think. And lots of customers ask us to be able to configure the function without changing the code. So this is a way to have the same code base running in production and in test. Maybe you change your database endpoint. You can put of course, the database as an endpoint as an environmental variable. You configure the variables here, like db and then the value, and you can add more, and they are available as normal environmental variable in the function code. So in Node.js, you would use process.env to read the content. Just for your interest, these variables are actually stored encrypted using our key management service that is based on an anti-tampering approach. That means that even if someone enters and conquer our data centers, we will either better destroy the content of these environmental variables than have someone read what's encrypted there. If the data that you store here is very sensitive, you don't want to put it in clear here, so we have this helper that can help you store the data already encrypted in the platform. This parameter here, the handler, is very important because it's saying in the whole code base that you pass to the function, which is the function, the actual function that you want to expose using AWS Lambda. Because if you upload some code, you will have not just one function. You can have tens, hundreds, thousands of functions. Only one of these functions will be the one that is invoked when you call Lambda. And you have to say which one it is. And the syntax is file name dot without the extension, dot the name of the function that you want to expose. So as you remember here, I'm using the console. Normally, when you will use it in production, you're not using the console. You can use command line tools and frameworks. And you can have more than one file in a function. If you use the console, we use by default index.js as the name of the file. So that's why you see index here. And then index.handler, because handler is the name of the export function that I'm exporting. So I can have more functions here in the code, and those will not be exposed by AWS Lambda. Then you have a role. Role usually is something that can create some problems to new people coming to cloud, because if you are used to work locally on your notebook, you don't care about permissions. But since this will run on a cloud environment, permissions and security is everywhere. So you need to give some permissions to these functions to do what they need to do what they're supposed to do. They may read files from one repository, write on another database. And we have a powerful syntax as part of our identity and access management service to give a role. And we have some pre-baked role that you can use so that you don't need to learn everything at the beginning, and then you can refine. I will choose to use an existing role here that I already have. It's Lambda basic execution role. And what do you think are the permissions that I need to give to these functions that basically is just getting an input and giving an output? Read only? Actually, this function is doing something, and I said that it was doing something that with another service. Write to logs. So as I said, this function is writing to logs. It's writing to console.log, and this is another service, so you need permission to write logs, because it's not that everybody comes and writes your logs to your own account. So this is very important. So we have a standard basic execution role that does that. If you forget to give permission to write logs, the function will fail to write logs, so we will find the logs completely empty. So if this happens, probably the mistake you did is to don't give permissions to write log, and you didn't use the basic execution, so check for that. Now we need to give some information on the environment where the function is running. As I said, we will provision one container, one Linux container for your function, and then we will run the code there. And you can give a maximum amount of memory to this container, currently from 128 megabytes to 1.5 gigabytes. And with the memory, also all the other resources of the container will grow linearly. So if you double the memory, you also are doubling the amount of CPU that you give, so it will be faster. And you also are giving more I/O capacity, so also networking will be faster. This memory is also affecting costs in a linear way. So if you double the memory, you double the cost of the execution of a function. If the function is faster, it may take less time. So probably maybe part of the doubling of the cost is absorbed by the fact that the function is running in less time. Then we have a timeout. Timeout is important because this is a headless environment. I just put here some code of a function. You can make a mistake and create an infinite loop in this code, and this function will run forever. and you will pay forever to AWS for this function running in the background. Of course, we don't want that. So that's why there is a timeout that currently can go from 1 second to 5 minutes. If you use the functions interactively, usually you don't need a lot of time. If you do some backend processing, you may use longer timeouts. The timeout is not affecting cost, it's only deciding when to stop a function. So usually you don't need to be very strict with timeout. I usually put some, like if I know that my function runs in 3 seconds, you can put 10 seconds or 30 seconds, because if nothing goes wrong, the timeout will not be used. So to say hello world, 3 seconds is more than enough, so I leave the default for now. The DLQ, the dead letter queue, is a new option that we added November, December, I think. It's a dead letter queue that in literature means if you have something that gives an error you don't know how to manage, you put it into this queue for processing. Basically means if you have a function that runs asynchronously and always fails, we will retry it a few times. If we see that we are not able to process this function, we will write the input event of this function in this dead letter queue, and then you can process and understand why this function is failing and do some debugging. You can put this into SQS, our queue service, or use SNS, that's our notification service, so you can choose depending on what you prefer. This option is really powerful for AWS users, is the VPC. So when you create an account on AWS, you can create a virtual private cloud. It's like your own private section of the AWS services. It's like a virtual data center where you create your own subnets, your own networking. Normally, a function that runs on Lambda has internet access, but doesn't have access to your own private networking, because that's only private for you. If you need to access your own private network, because maybe you want to read something from a MySQL database that is running in your account for reading users or writing some information, here you can select the VPC and the subnet in your account, and then you will have network access to your own virtual private cloud and virtual networking. And finally, if you use encryption with the environmental variables, we will manage the master key for you with the standard master key. You may want to create your own master key, normally because if you create your own master key, you can give access to the key to different people inside your organization. So maybe someone has only read access to the key, another person has write access and can rotate the key, for example. So if you start to have some more complex management of your encryption keys, you will not use the standard one, you will start to create your own. So lots of time, but basically I cut and pasted the code here, and all the configuration were the default. I just added the basic execution role. So this is the classical recap, and now I created my first function. Now that my function is created, I can test it straight from the console. And if you remember, I needed a name. Let's use Danilo. And this is plain JSON. Now I save and test, and wonder of the wonder, we got hello Danilo as output. Just to do some regression test, I can maybe remove everything and pass an empty JSON object. What will be the output? Hello world. So our function works, and even if it seems very stupid, we just created a function that can run on the cloud. You can invoke it once per month or 1,000 times per second, and you don't need to think about availability, scalability, patching the operating system, patching the Node.js or the language frameworks. You can only focus on the functionality. So the code base is very small, and all the dependencies are managed by AWS. So we just created this first function, and now you can call this function also from any device using the AWS APIs. So we have this first function, and you can use any device. You can use a web application, you can use a mobile device, an Internet of Things device. Using, for now, the AWS SDK, you can use the Lambda API. There is an invoke command to invoke a function, pass some input, and get some output. Usually at this time, I like to abstract this, so any client application would work. As a suggestion, you should think that everything that you can run on the client, make it run on the client, like you would do for a mobile application, extend the same concept to web apps. And then only if you need to have some security because maybe you are moving money, so you don't want to let the data work inside a mobile app, or you're sharing information, or you need additional capacity that are not in the device, so more computation, more storage, then you have some function that you can invoke in the backend. Functions are stateless, so when you invoke them and then they terminate, there is no state that they keep. There is a temporary file system, but you don't want to use that. So you should think that functions are stateless, and this also gives a good approach in programming. And if you need to persist something, you need to read or to write on a database or in a file storage. So most of the times we see customers using Amazon S3 as an object storage or a database such as DynamoDB, but you can connect to MongoDB, to Redis, to MySQL, Postgres, whatever. And the idea is that when you work on other services in AWS, for example, Amazon S3 or DynamoDB, you can trigger other functions. So if you write something, now also if you read something from S3, or if you write something on DynamoDB, the NoSQL database that we offer, this can trigger another function. And in this way, you can link stuff together. For example, if you create a media sharing application, you can have users upload content on Amazon S3, and with the picture or the content that they share, they can bring some metadata. And when the content is uploaded, you can trigger a function that reads all the metadata of the picture of the document that they uploaded, and then can then index this metadata in another repository. It can be DynamoDB, it can be Elasticsearch, or whatever. So this chain of reaction can create more logic. So your business logic can be built with all these functions that can be directly called by a client application, by a mobile device, by a web application, or can be triggered by events that happen on storage repositories or other services. And for people that comes from a more structured architecture, we start to see that all three layers are still there. So the flow is different, but it's still you have a client, you have some business logic, and then you have some data persistence layer. And you can put things like this to make it a little bit easier to see. So the client, the functions, and the repository. So for now, the API that you can call, that you can use from the client is the AWS Lambda API. And this works, you use AWS security to protect that, but you may want to decouple the client from AWS. You want maybe to create a client that can work on different backends, and maybe use a standard API that you want to model. And another thing that I was almost forgetting is that you can also directly access the repositories from your client. So if you use DynamoDB or S3, you can upload a file straight on S3 from the device, like a picture, or you can edit something in a database straight from the device. So you can have this as a loop where the client is uploading a picture, this triggers functions that work in the backend. But if you want to decouple this, you can put an API gateway in between, and the API gateway role is to translate a standard API that you can define with the backend implementation that in this case is built using serverless functions such as AWS Lambda. We have a product that is called Amazon API Gateway, and you can use that to give an HTTPS interface to Lambda function. But here, in my view, this API gateway is a broader concept. So anything that can map one protocol to AWS Lambda. For example, we have an IoT platform, the AWS IoT, that can do the same from MQTT to Lambda function. MQTT is a very lightweight protocol that internet device like because it's much lighter than HTTPS, especially if you run on batteries for 1 year. You don't want to do HTTPS because it's very heavy. And you can put the AWS IoT and the client can publish via MQTT that is very light and can get even a response back via MQTT. So think of the API gateway as a broader concept, not just the service. And now let's get the previous function and transform the function in an API. So normally what you would do would be to take your function. You have some data model, you remember you have an event.name, and then you get a response. And you need to teach to the API gateway to map this input-output into the HTTP standard way of communicating. For example, the name can be a query parameter or a header of the HTTP request. And to do that, with the API gateway, you can use velocity templates. So it's a standard syntax from the Velocity project that you can use to map input and output of the API gateway. But over time, we realized that all the customers were doing the same again and again, because most of the API are relatively simple, and you needed to write a template to map one parameter to another. So we decided to leave the option of using velocity template. But now you can also use a standard syntax that we propose. It's called Lambda proxy. It's the default implementation with when you create a Lambda function. And in this way, you have a standard syntax that remaps every information of an HTTP request to an event for a Lambda function, and then on the way back. So let's use this. It's a little bit more code, but at the end, it's very simple. So let's create a new function. So I go back here, and let's call this function, it's a blank function. Now this function, I want it to be triggered by the API gateway, and the default integration will use this Lambda proxy syntax. You can give a name to the API. It's just for your own management. Lambda microservice is OK. You can give a stage. This is because the API gateway has the concept of stages. You can use stages for having like a test stage, a production stage, and this will be part of the URL of the API. And then you can move rollouts from one stage to the other. So you make the change in the test stage, and then if it works and pass your own test, you can move it with either a click or a command to the production stage, and so on. Here I'm just using production. Then you have security. The API gateway can secure access to the API in lots of different ways. I'm not entering into that, but for now, let's create a completely open API so it will be easier to test and debug. Now I have to give my code again, so let's call it greetings API. It's still a Node.js, and I have the code here. So as you see now, the code is longer, but it's mostly due to checks and my bad JavaScript code. So I'm using strict here. You see there's still an input function with an event, a context. And now what I do, from the event, I can look into a standard syntax that will bring me all the invocation data from the HTTPS request. So the event.query string parameters will contain a dictionary, so a JSON object with all the query parameters in the request with the value. And I'm just to be sure, I check that it's not null, it's not undefined. If there is a name, I take this name, this event.query string parameters.name. I also look for an HTTP status. This is an additional functionality, just to give you an example, in the query string parameters. If there is an HTTP status, I store it as a response code. Now that I have the input, I can build the output for the API gateway. I create a message body that is this is a syntax that works in JSON, so I'm returning JSON. But this depends on your API. It will be actually a string that can be JSON or XML or whatever you want. This message, it will be hello plus the name, so hello Danilo, hello world. I also add the event as input, so that means that everything that I get in input, I send it back in output for debugging, to give you an idea of what kind of information I receive. And then I build the response. In the response, I can change the HTTPS status code from 200 to whatever I want, and I use the response code value. So if I receive a response code, I can use that to change the response code of the HTTP request. You can change the headers. And in the body, I'm using the stringified version of the response body that I just built. So that's why I was saying it's just a string, because here you can put whatever you want. So this body is given back. I log it and I give it back. So for the rest, everything is as before. So I can create, I will use the same role as before, the basic execution role, because I still want to debug. 128 megabytes is enough, 3 seconds is enough. I don't need to change anything else. This is the classical recap. And now I'm creating this second function. And since I integrated the API gateway, I also get the endpoint here. So if I click here, as you can see, we got the message, hello world, because I didn't pass any parameter. And in the input, I have a cut and paste of everything that was received in the input event. So you see, you get the resource, the HTTP method, it was a get, the headers, and somewhere here the query string parameters was null because I didn't pass anything. If here I add a name equal Danilo, and of course the content here must be translated with all the escaped characters if you put something stranger than plain ASCII. As you see, now I get hello Danilo as a message, and if I look here, I have the query string parameters is a dictionary or JSON object, a Java object where I have a name and a JavaScript object, a name and my name. So this is the way it works, and you have all the other classical information of an HTTP request. So this is a standard integration. Now we created an API that can be, of course, protected. And this is an API, again, that scales as much as you want, and you only pay if you call it. So let's go back to the slides and see something more. So at this point, lots of people ask, how can I start and do something more interesting than hello world? Because this is a very basic example. So you can start using Lambda. Just as a recap, you don't need to manage the servers. There's continuous scaling from our side. You can call these functions or this API once per month or thousands of times per second, and we will manage that for you. And the way you pay is metering that is sub-second, because with Lambda, you pay the invocations of the function and the hundreds of milliseconds of execution time. So every time you invoke a function, we look for how many hundreds of milliseconds the function runs, and you will pay for that. So it's very, very granular. Any optimization you do in the code can potentially reduce your bill. So usually developers are more involved in the optimization than normally. And there is a quite big free tier. This free tier is for everybody. So some free tiers that we have on AWS is only for the first year, but here is for every account always. Every month, the first 1 million of invocations and the first 400,000 gigabyte seconds are for free. Gigabyte seconds means that if you use function with 1 gigabyte of memory, you have 400,000 seconds of execution time. If you use less memory, you have more time, because as I said, the price is linear. So if you use half gigabyte of memory, you have 800,000 of gigabyte. If you use 128 megabyte, the minimum that I used before, you will, this 1/8, you get 3.2 million of seconds every month for free. So normally that means that if you are a startup, you can start using Lambda, create your product, and probably go in the range of the thousands or even the tens of thousands of users without any cost on Lambda. I think this is a good way to start and create a new project. Of course, as I said, you want to build something more interesting than Hello World and all the possible permutations. So this is a project that I suggest you to look. We presented this at reInvent, our yearly conference in Las Vegas in December. And it's a complete project. There are two main directories. The /API directory is the backend implementation of a reservation system where you can book rooms, create new rooms, and book them in a calendar. And the /app directory is a Ionic mobile app, so a mobile app written in JavaScript with all the code to build the client side that you can use for a mobile app, but since it's JavaScript, most of the code would apply also for a web application. So you can see how to correctly invoke an API gateway, how to protect access. There are two levels of authentication with non-authenticated user, and administrative user that have more rights, like creating rooms that you can book. So you can see all these best practices in this code, and there is a tutorial to build this application. So this is a repository that I suggest you to see. I will give the slides so you don't need to take pictures, and there's a recap of all the links. Another way to start, if you're not on the JavaScript side, but you're more on the Python side, we have this micro framework. It's called Chalice. And basically what it does is use the very simple Python syntax that you can find in micro frameworks such as Flask or Bottle. Maybe some of you used it. And the idea, this is a very simple way to start. So you use, this is Python, so you use pip to install it. you create a new project with the chalice command, and then you have an app.py program that has a syntax that is very similar to Flask or Bottle. Those are micro frameworks like Sinatra for Ruby, for example. And basically, you create an application and then routes, like slash or whatever you want. And these routes have some function linked. And when you create this app.py, a single file with all the routes and the functions that can also call external objects, external code, you can then do chalice deploy, and we will create the Lambda functions and the API gateway configuration for you to have a web application that will implement these routes and this code. And of course, it's much more powerful than this. For example, you can pass parameters as part of the URL, and these are passed to the function, like the index function here. So it's very similar to what you would do with Bottle or Flask. So if you're on the Python side, this is a very good way to start. Generally speaking, we see lots of developers that have no knowledge of AWS, that they don't like to come and use the web console for programming. So this project is an open source project that started from very nice guys in the US, and it started with a different name. It was called JAWS, and then they changed the name to Serverless Framework. And it's a complete framework similar to the framework that you find normally with JavaScript, like the Express framework. So you create your own project. This will create all the scaffolding, all the directories for you, the standard configuration file, and then you can create APIs and the logic behind these APIs with a very standard syntax. So it's another way for starting with a serverless technology. And this is probably not the most enterprisey reference that we have, but I like it because it was one of the few ways I could explain what I do to some of my friends or some of my relatives. You may remember the last European football championship, and David Guetta was in charge of the anthem for this championship. So when he was creating this song, he said, yeah, I would like to have some fun singing with me. So how many people do you want to sing together with you in the anthem for the championship? Said 10, 100. They said 1 million people. I would like to have 1 million people singing to me. So there's this relatively small company based in UK. It's called Parallax. They built all the backend and the client application. It was a web application using Lambda API Gateway and S3 to store the actual song, where people could go on the web and sing, and this audio file would be stored, and then they could remix all these people together in the final version, in the final editing of the song. So I like it. The final cost, of course, was really ridiculous compared to how this project is, the visibility of this project. Another question that I often get is, okay, I like the approach, I see that there are potentials, but I work for 20 years with different technology, now I have to rebuild everything. Likely enough, no, and also thanks to the community. So we are seeing lots of frameworks. Some are supported by AWS, some are just created by the community, to take, similarly to what Chalice was doing, standard syntax and translate automatically this syntax to the Lambda and API Gateway approach. So this is the AWS Serverless Express framework. And with this framework, you can take a normal Node.js Express application and package it as a Lambda function with all the necessary integration with the API Gateway. This other framework is for Java developers. So if you have an application that runs usually JAX-RS or Jersey Spark, you can map this into Lambda and API Gateway configuration. Let's just have a quick look to this. So I should have something here, as I usually, oops. I don't need to link anything. I should have something here. Okay, it's not here. Maybe it's, as usually, I didn't double check, so I think it's. Okay, let's start a nice find. Also, let's see online, because I already packaged it online, so it will be easier. So basically what this framework does is that you have a repository that you get out of GitHub that has an example directory, and in this example directory you can put your Node.js Express application, and this will be packaged using CloudFormation. It's our infrastructure code service, and with CloudFormation you will create all the resources that are required by this application. So I should have everything either here. Yes, it's here. So basically you package everything and you get the output of your application. So this is a very simple application that they give you. It's like a very basic REST interface to get users, post users, and create new user ID. And this is the application. Then you can use the API. And this is just a standard app.js Express application that was translated to the Lambda world. So you can use this this repository to do that. Another question that we often get is how to go beyond the timeout. So I said there's 5 minutes is the maximum timeout, but lots of backend implementation may need more time. So let's say you have to process thousands of files. So there's a lot of tricks to do that. This is my personal suggestion. So these functions are really flexible, and the same function can also invoke itself asynchronously. So the idea is, in your function, you get a list of items where there's all that stuff that you need to do. And then you get the first item from this list, and you remove it. You process the item, and the process item function here will be the custom code of your function. And then when you terminate this function, okay, if the item list is empty, I finished, and that's it. If it's not, the length is not finished, so I still things to do, I can use the context. You remember the object context is giving me information on what is happening in the execution environment. And one function is the get remaining time in milliseconds. It's telling me how much time this function has left. So if the time left is greater than some threshold, so for example, I can say, I know that to process one of my items, I normally take 2 seconds. So if I have more than 5 seconds, then I can process this item and the next item. If there's no time available, I invoke myself, the same function, asynchronously, with the remaining list of the things to do. So I still have to do something. I will invoke myself asynchronously, so this function will terminate, and the same function will start again with the remaining things to do. And then you can continue process them, and then if the time is running out, it can invoke itself again. So any job that can be splitted in chunks can have this approach, and you can run for hours, because every 5 minutes you basically terminate the function and invoke it again with the remaining things to do. Nice thing is that if you run all these functions sequentially, or if you run all these functions in parallel, you will pay exactly the same. So if you run in parallel, you get the result quicker, and you pay exactly the same. So you can change the code and run and invoke this function in parallel. So if you know that a function can do 5 items before the time's running out, you can invoke 5 other times, and you have the result probably in a few minutes. So think also that with function, everything can happen in parallel. What about larger applications? We saw very basic examples here, and you may have, of course, if you create a larger application, it's much more difficult. So for this reason, we released this serverless application model. I don't think I will enter into too much details today, but the idea is that we want to create a standard syntax to describe a serverless application that can have multiple functions, that can use different repositories, such as database and file repositories. And these functions can be triggered by events on those repositories. And we don't want this to be only something specific to AWS, so we created this standard syntax that it's available with an Apache license. So everybody in the community, everybody in the industry can reuse the same syntax to describe a serverless application with multiple resources, and this base syntax will be available to everybody and simplify usage and portability. This syntax is also enabling nice use cases, such as creating a serverless continuous integration and continuous deployment environment. Because if this is your code base, you can use GitHub or other services to host your code, such as just a zip file on S3, or can be our code commit Git managed service. When you commit the code, for example, on GitHub, you can trigger another service that we have is AWS Code Build that can build and package the function. Package because in the example that I did, there was just a single file. But if you have dependency, you should bring all the dependency like the Node.js modules with you. So you need to zip everything. And you can use this service that, by the way, has a free tier again. So the first 400 minutes every month for this service are for free. So you can, if you don't build for more than 400 minutes in a month, you can use this for free and then you pay by the minute. So you package the function. You can also use this service to execute tests if you want. And then you can deploy automatically to production, because using the serverless application model syntax, you can give this syntax to the CloudFormation service, the same that we briefly saw. And this service will take this configuration. The first time we'll implement all the functions, all the configuration of the repository. If you update something, this service will update the resources that are already there. So if you update one function and you give the slightly different application model, this service will incrementally update. It can also create a change set that can tell you, okay, this is what you have in production, this is what you want to change, you want to approve this change set, and you can say yes. So it's really a powerful approach to manage production. And as I said, I don't want to dive too much, dive deeper on this today. For very complex functions, especially for complex business process, we also added this feature recently. It's called step functions. And how many here studied computer science? So maybe you are familiar with the concept of state machines, one of the most boring topics maybe at the time. So state machines, the idea is to give a state machine as a service. So you have a state machine where you can describe a complex flow that can be sequential, can be with multiple branches, can happen in parallel. And with this, each of these nodes can be either a Lambda function or code running whenever, because you can integrate any code here. There's a few APIs that you can use to do that. And this process can not last far more than 5 minutes, can last also, I think, 1 week or 30 days, so lots of time. So for example, you can use the normal API approach for the very fast interaction with your website, but if you have a purchase operation, that it's a complex operation, because when you buy something on a e-commerce website, you have to check the availability of the product, you have to look for start the delivery process, you have to check the payment if it went okay, maybe you need to send an email to acknowledge the status of the process. So this is not something that you want to put into a single Lambda function, because it will very easily grow and become too complex. So you can create a workflow that will maybe integrate with multiple microservices and model this as a state machine. And to describe this state machine, we created this specification. We call it the Amazon State Language. It's a JSON language where you can describe any complex state machine status. And again, this is available as an Apache license, so that anybody in the industry can reuse it and never discover the wheel again. So just for a little bit more clarity, here in the console, you can call the stem functions. And let's go in Ireland. And with this function, we have some prototype here. So, for example, you can do a retry failure of a single function, and this is the code. And managing retries in production is really hard because you should manage different cases. And this very simple workflow is just launching a function and retrying the function if it fails. Already implements something that we use extensively in Amazon and in AWS, that is the backoff rate. So if you have some function that fails, one of the typical problems is maybe I received a huge peak and I want to spread this request. And the backoff rate is doing that. So you can set up an interval for the retry. How many retry you want to do, 2 or 20 retries. And then the backoff rate will increase the interval using an exponential backoff. So every time you retry, you double, because it's 2.0, you can use a different value, the interval. So I retry after 1 second, then after 2 seconds, then after 4 seconds, 8 seconds. And this exponential backoff will naturally spread the peak of request into a large amount of time. This is very convenient, because if you have an issue, because maybe a database that you use has some performance issue with the peak, this will automatically spread the request and retry them so that they don't fail, and the peak is absorbed by something that is outside the scalability of Lambda, like a normal database. And of course, you can do parallel branches, catch the error from a function. So if in the callback you raise an error, normally this error is given back, but here you can catch the error and process the error, and depending on the error, you can launch another function. So you call the hello world function, and if the hello world function fails, you have different functions that, depending on the pattern that you find in the error, can be invoked to process this error and react to in different ways. So you can build very resilient infrastructure. So this is quite a powerful feature. As I said, I would not use step functions always. I would use them when you have the single API that is very complex and that probably is invoked not always like the purchase operation of an e-commerce website. That is the most important one, but it's not the one that is invoked hundreds of times per second. One point that I mention often is the event-driven architecture, and this is very important because it's the way you can build larger applications. So here I think backend developers need to think a little bit twice, because in the backend usually we are not used to build event-driven or reactive, as we often say now. But in the front end, this is quite common. So if you talk with the front-end developers and you say, okay, this is a very ugly user interface, but I can link actions to this user interface. So if I click submit, the new user is created with an API call. And this is normally implemented in the front end with the observer pattern. So you have a user interface. You can create targets that are monitored by observers. If something happens on those targets, some action is triggered. The idea with Lambda is that you can do the same in the backend, where instead of UI components, you have other services, such as repositories of files, databases, or stream of data, like with Kinesis, that comes from maybe Internet of Things or other devices. And if data comes, this can trigger an action. So you can generate thumbnails for a picture that is uploaded. You can look for changes in one database and synchronize another repository, or you can process a stream of data. The idea is that this is difficult for a normal backend developer because it's not used to think in this way. So for example, how many people would say that they are backend developers here? What do you see here? It's a joke, so it's not nothing. A function. And front-end developers, what they see here? Maybe you can also see data binding. So area equal this multiplication. So usually, if you come from procedural programming, you see this is a function. But if you come from reactive programming or front-end, this can be implemented with data binding. So I'm saying, okay, the area is bound to the value of these other two variables. So every time I change the length or I change the width, automatically the value of the area is updated to this new value. So data binding is very much used in reactive programming. The idea is really that you need to take a different point of view and start to think not in procedures, but to react to changes. And if you start to have multiple services, that means that, let's say that you have two services or two functions, function A and function B. This graphics means, okay, if I run function A, that maybe it's a new user is created, I need to trigger function B. That means, okay, I need to send an email to the user to welcome to the new platform. And this means that service A or function A is triggering service B, or you can see it as a cause effect. So I'm saying that service B, the email, is caused by the fact that I created a new user. And thinking of cause effect in programming is really useful because we were talking with this before. Our brains has been evolved for millions of years on thinking of cause effects. And very often we also see cause effects where they aren't, and we make mistakes, but normally it's the way we are used to think. So think of, okay, this process is causing this other effect. And then you can extend this to multiple services, and this can also be cyclic. So let's say that you create a user, you send the email, the user click on the email, so service C maybe is triggered by the user verifying the email, and then you can have a final function that goes back to a first service to say, notify, okay, the business process has completed. So in this way you can have a very complex process split across multiple functions, and one of the last function will go back and notify the status of the process. And if you look at this very complex graphics, and let's be the developer that is writing function B. This function B actually only needs to have local visibility. So this function, when you are the developer, needs to know what are the input events, so I can receive an event from service A, a new user has been created, or service function E, the user has completed the creation. I don't need to know anything about input from C, D, F. They're outside of my scope. And I need to know which is the logic that I need to create. So if I receive these input events, I need to update a database, I need to do something. And I need to know what other functions or what other services I need to trigger. So I need to call the service that verifies the emails or does something like that. I only need to know this small vision. So if you have a project that has 100 functions, each function has local visibility. You need to know input, output, and the local process. This simplifies the logic and the development a lot, because it's very easy to get lost in a complex workflow. In this way, you only need to know input, output, and the local logic that I need to implement. It makes the developer life much easier. So for people that love software architecture, we are saying it's better to have a distributed data flow instead of a centralized workflow, because every time you add something to a complex workflow, everything is correlated, and it's very easy to make mistake. We are favoring choreography instead of orchestration, because we don't want to have a strict orchestration of how the functions are called. We want to give a choreography. So if this happens, you have to do this. If this happens, you have to do that. We don't want to create a strict process. And of course, we are talking, and you notice that because I use the word service often, of microservices, because the small functions, at the end, they behave similarly to microservices. So we are talking about a distributed system. So we need to be careful, because in a distributed system that runs on multiple servers in multiple hardware devices, you need to think that there is time and space. Time, because things can happen concurrently or not. You can control time on a distributed system because things happen on different hardware devices. And latency. So when you develop locally on your laptop, everything happens at once. In reality, there's latency, there's the speed of light. And space is important because everything that you execute can be distributed to different devices, so you can't have a shared local folder, for example. But you get mobility, so you can have availability and scalability because this function can run on different hardware. So you need to think about this. Often, another question that I get is how big the functions should be, because in the example that I gave, I was using very simple functions. But if you start to build a very small function, you can have hundreds or thousands of functions, and then it can be complex to manage. So normally, the guidelines that I give, it's the same for functions, serverless, or microservices, is look at the data. If you have multiple services using the same database and the same repository, you are probably tying these functions, these services together. And then if you need to change the schema in this database, you need to update all these functions at the same time, because otherwise one can fail or can be complex. The number one advantage of microservices, in my perspective, is that each service can be deployed independently, so that if there is a bug, you're not stopping someone else's work. So if you see that you are creating dependency, and this usually starts with data, then probably these two pieces of logic should be put together in the same function. Data should really drive the boundaries of functions and services. And using repositories such as database, it's different because things happen asynchronously. You don't know the order of that, because if you have two updates on two different services, you don't know which one will arrive first on the database. So from the classic ICID model, you should think in a idempotent way, so that updates on the database should arrive in different orders, but these different orders should be perfectly accepted by your data model. Think that everything can happen in different orders, and you should design for that. The advantage that you get is that you can scale very easily from a serverless architecture to production, because everything that you build is managed and can scale. If you want to create something that can scale, my suggestion for software architecture is think of the reactive manifesto. This is a very good high-level approach for writing scalable distributed software. And if you look at the main characteristics of the reactive manifesto is that software should be elastic, and Lambda functions they are, because they will grow and shrink depending on your throughput. Should be responsive, and we manage the availability. And if usually even if you make a mistake, you get an error, that it's much better than silence when you call someone. And resilient, because we will find the hardware to run it. The only part that is not enforced by using serverless technology is the asynchronous communication. So if you have multiple functions that communicate, like in the example before, think that they need to communicate whenever possible asynchronously, like in the example where the function was invoking itself asynchronously. Because if you have a piece of software that communicates synchronously, you're not using microservices, but it's a distributed monolith. Because everything, if something fails, everything fails in the neighborhood. So this is where a developer should be really careful. Just to wrap up, we are thinking as AWS of having Lambda function run outside of our data centers. So we started this with the latest reinvent. So these functions normally, as the one we create, are in a region like Frankfurt or Ireland or in the US. But people may want to run code locally. So we launched this project. It's called AWS Greengrass. It's basically a gateway device that can provide communication from the IoT platform using MQTT data caching and Lambda function execution locally. The requirement to have a Greengrass device is to have something with 1 GB of memory and 4 cores, and can be an Intel processor or an ARM processor. So basically, a Raspberry Pi is enough to run Greengrass, and you can run your own Lambda function locally, and you can still manage everything from the AWS API or the AWS console. So you have central management for a distributed architecture. We think that edge computing, all these devices that are going to be distributed, not for centralized processing, but for local edge requirements, is going to be a big trend in the future, and this is very complex to manage now. Think of all the issues with security and IoT, for example. So I think this is really important to help our customers. And this Greengrass software runs also on some of our devices. So Snowball Edge is a physical device that you can ask from our AWS console. We ship it to you. You can keep it for, I think, 10 days. Then there is an additional cost. And in these 10 days, you can connect it to your network and copy your data. And you can use this to ship data from your data center to AWS, or to move data from that AWS to your data center, if it's more than what your network bandwidth can support. One of these devices can have 100 terabytes of space, so it's much easier to ship 100 terabytes than to upload it using FTP. And actually, some of the requirements that we saw are really interesting, like if you are collecting data in a mine below the ground or in the middle of the ocean, you can use this info to collect data, start pre-processing with local Lambda function, and when you reach the port, for example, from a ship, you can connect and upload only the processed data to AWS that is smaller, and to have a faster analysis of your data. So we're seeing very interesting use cases with this. If you need more than 100 terabytes, you can order more, and they cluster together so that you have a single endpoint, and they scale to 200 terabytes, 300 terabytes. if you need more, we also have the AWS Snowmobile that actually came on stage at re:Invent. So I was there, so we have this truck entering the stage of our event that is filled with similar technology and can arrive to 100 petabyte, plus lots of networking, because to move 100 petabyte of data, you need a lot of cables. You can just upload with a single cable. You can't order this with the console. You need to contact us. But we are seeing customers in spaces like genomics, where the amount of data that is analyzed is huge, and this can enable new use cases, because you can move 1 exabyte of data in a few months, while before 1 exabyte of data was simply something that couldn't be moved. Last point is Lambda at the edge. So you remember there was this Node Edge platform available with Lambda. We have this idea is currently in preview to have Lambda function running in the edge nodes of our content delivery network. So the idea is sometimes you need to do the final customization of the content that you want to give to your user, but you don't want to do that centralized. You want to do that based on a cached version, very close, low latency to your user. Think, for example, of all those web pages where the only thing that changes is the name of the customer in the top right. You can do that on the cached version locally. You can use this to do A/B testing. So depending on the customer, you can serve different version of your website or different version of your results, and then you can monitor which one is better for your customer. You can also do this for advertisement. This company doing like picture advertisement, so advertisement in picture. So you have the cached picture, and then before serving the picture to the customer, you add some advertisement information to it, so that it's going outside of everything that you can block normally. But it's interesting if you do that in an interesting way, not knowing your customer. So it's in preview. Currently, the timeout for Lambda, you can guess how much is the timeout for Lambda function running in the edge. So this is for very low latency use cases, because if it takes lots of time, you can do that centralized. It's 50 milliseconds, so it should be very fast function that takes some content and quickly customize so that you can be very fast and use the cache capability of a content distribution network. So final advice, if you want to build application using cloud services, always think that you're not using or renting capacity, you are using a service. So think of that and think of building application with services, not with some rented physical resources. This is for your reference, everything that I talked today, including the repo of my book with all the code that I use for my book. So I'm open to questions, and then we will give away this copy of the book. Thank you. So I think we have a mic for questions.
Yeah, here it is, yeah.
Perfect.
Thanks. Yeah, thanks for your talk. It was quite enlightening, I think, to think about that new model. Have you observed teams that heavily rely on that new model, and how does the development workflow develop with people relying heavily on edge computing and stuff like that?
You mean serverless or specifically edge computing?
Both, yeah, your experience.
So talking about serverless, as I said, edge computing with Lambda is something very new. We're in preview, so the use cases are the one that I saw. So A/B testing, advertisement. For serverless technology more broadly, we are seeing huge application in lots of companies. So we have startups that start from scratch with serverless because they don't have a legacy. So we have, for example, a digital asset management platform that can be built using static content on S3, and then you react to someone uploading content. So it's very low cost, very easy to manage. Staying in this area, there was like a company in the Netherlands. It's called Binder. When we released in December a new service that is doing image recognition, they added to their digital asset management automatic tagging of the pictures that are uploaded. For them, it was a Lambda function on S3. Every time a user uploads a picture, you process this picture with the Lambda function, create the tag, and write the tag in the standard tagging service. So the impact on the application were minimal because they use the upload that was already in place, the tagging service that they already built. They just needed to bridge this with a Lambda function. So probably we are talking of tens of lines of code. So this is a very easy way to start adopting this. When you start to work with this technology, times get faster. So you are very fast in building prototypes. Like Adrian Cox recently said, sometimes it takes more time to talk about things on Twitter than to actually build them with Lambda. And probably if you follow some Twitter threads, you know that it is probably true. I think the idea is that really you can build a prototype very quickly, and this prototype is ready, almost ready to scale in production with very little changes. Then if you need to optimize costs, it's something that you can do. But for a startup, it's much better to don't fail the peak when they become popular, and then maybe they can optimize, than to build something very cool, but then if someone writes about you and they reach your website all at once, you fail and you lose your customers. The microphone for the question.
I have two questions.
Yeah.
The first is about interoperability / lock-in, and the second is one size fits all. So let's start with the first. And it seems that there exists multiple libraries to make existing projects compatible with AWS Lambda, but the reverse is not really being promoted in any way, because if I were to invest in migrating my architecture to AWS Lambda, and for some reason I decide that this is not optimal for me, then I have a lock-in solution that I'm not easily able to migrate away from. So is Amazon supporting not just a standard, because AWS SAM is only a standard, like an open source runtime where I can run my Lambda functions? That's the first question. The second is, it seems that AWS Lambda is like a one-size-fits-all, where other solutions exist for example, batch or stream processing in the Hadoop, Spark communities that are more optimized for quote-unquote big data processing rather than like hacking the way to work around the timeout. Also, the build stages available through AWS Lambda seems very limited, because I have to create a deployment package where everything already exists and I push it up to AWS Lambda. But if I were to use like a general platform as a service, like the one provided by OpenShift or Heroku, I can do lots more during the build step of my service rather than just provide a zip file with all the source codes. So what cases do you think AWS Lambda is optimized for? And do you really think it is a one-size-fits-all solution?
Okay, thank you for the question. So the first question, to make it simple, is, okay, if I want to develop everything in Lambda and then I want to leave the platform, what happens? First of all, I can assure you that we are listening to our customer. So this is something that is being asked, so we are thinking how we can help in this area. But with what we currently have, my answer normally is, okay, if you use Lambda, you don't need to manage the installation of the container for the logic. You get simplified security because you get all the framework for security. You get scalability. You don't need to manage a load balancer and so on. So if you leave the platform, if you think it truly, most of the cost of leaving the platform will be in implementing everything that Lambda was providing you for free. Because the code is still functions that you can copy and paste and you can put in your code. So even if leaving the platform is not easy, I would say that the great majority of the changes that you need to do today with what we have would be mostly to do what the platform was already giving to you as part of the features. Apart from that, as I said, we are listening to our customers. We are thinking about we can make it easier. For example, like with Snowball, we both support to load data and download data using our physical device. We're thinking how to improve this for Lambda developers. Did I answer your question?
Yeah, for the first part. The second part is about it seems that AWS Lambda is being promoted as a one-size-fits-all.
So, of course, I'm quite an enthusiast of Lambda, no? So I can see maybe use cases even when there is no use cases. But I think it's a different way of using computing. As I said, no, with the example with the I love the example of the recursion where the function is invoking itself to overcome the 5 minutes, because it's a different way of using resources. Now, if you use to server, you don't think about timeouts or stuff like that, but you have a finite amount of resources. With Lambda, you have timeouts, but you can access infinite amount of resources by a single function. Normally, like until 1 year ago, I would say MapReduce or stuff like you do with Hadoop is not a good fit for Lambda. Then a colleague of mine is based in San Francisco, and this is available on GitHub. He wrote MapReduce for Lambda. So this was for a startup that was finding running Hadoop too costly because they needed to run very few queries. So basically, he did a function that you can invoke. You put your data as files on S3, and this will apply MapReduce to files on S3, and it's purely running on Lambda. It's using the fact that a function can invoke multiple functions that do the mapping, and then the reducing phase in parallel, and then you get the consolidated output. So I think it's not something that is changing everything, but it's a different way of using computing resources. I see lots of potential. I would not say this is not working with Lambda. I would say if a new use case pops out, let's see if it makes sense to use Lambda in this different way, because you get the advantage, but you will probably need to change. As I said at the beginning, I don't see that serverless is changing the way we develop application overnight. I see it as a developer as a trend. I see this is where probably programming is going in the next few years, and probably this is something that I should care about. Make sense?
I still think that's being promoted as a one-size-fits-all, where other established platforms are more mature. So, for example, if you're doing like machine learning, most of this stuff is already well done in other.
Yeah, but for example, again, it is the same guy because he's really bright. He made MXNet. Apache MXNet is the framework that we bake for machine learning as Amazon, run inside a Lambda function, not for the training of machine learning, but for when you have a trained model for serving the content. So again, something that will say, okay, Lambda function is not for machine learning, but if you are a company that builds a model and then serves this model via API, you can do that with Lambda function. He wrote the function, he overcome some of the limits that you can find in normal Lambda function. So that's why I say, don't think, okay, this is not for Lambda. Maybe it's not, but it's really a new way of using computing resources. So maybe you need to change something in what you do, but if you want, you can explore the normal way you do MapReduce, the normal way you do machine learning, using a different approach to computing that is not dedicated servers, it's APIs, basically.
Are there plans to introduce more runtimes, and do you have a roadmap?
So we are continuously working on that. So we updated, for example, Node.js last year. We are thinking about continuously updating the runtimes that we have and add more runtimes, and also to make it easy for people to use other runtimes, because I didn't mention that, but with Lambda function you get a whole Linux container that is a binary environment. So there's lots of people using Go with Lambda today, because you can use a very light Python or Node.js function as a wrapper, and then you get the communication, and then you talk to a Go binary that is running in the container. And these things that can be a little bit complex to do by yourself, there are frameworks such as the one that I showed that can handle this for you. So you write Go code, and then the framework will package the code to run in Lambda using a Node.js or a Python wrapper. So we are working on that, but as per today, if you want to run something else, it's already possible. I think there was a question here.
I was just thinking about when you mention stateless and be able to scale without thinking too much. Okay, let's forget for a second S3 and let's think about Dynamo, a relational database. But let's take Dynamo, for example. I'm thinking, okay, I have my standard web application. I move from an auto-scaling group and move to Lambda. I re-implement it. Everything works fine. I go from one request per minute to whatever. and I map it. Still, I'm talking to Dynamo to store my session, to store anything that I don't want to have. I want to have it stateless, so I store it there. Is there any pattern, is there any advice on how to avoid? I mean, I don't want to pre-provision for the maximum peak my Dynamo to 10,000, otherwise, what's the point? I mean, the most costly part then is going to be my Dynamo database. Is there any advice, I don't know, any pattern where you have, I don't know, schedule lambda or something that takes care of provisioning the kind of legacy part?
This is a very good question. So DynamoDB, as that I mentioned often, is a non-SQL database that we manage. And you pay by the storage, but you also pay by the throughput, because the idea is every time you create a table, you can set a read and write throughput. We will provision that, and you pay by the throughput. If you have peaks, you don't want to set for the maximum throughput, otherwise your costs grow. So as per today, the best solution that I've seen used by lots of customers, and one of these is in Germany that I am aware of, there are very easy scripts that you can use to do auto-scaling with DynamoDB. Basically, you monitor the metrics on CloudWatch. So you set, let's say, a throughput of 100 reads per second. You on CloudWatch, our monitoring platform, you know that how much you are actually doing. So maybe you're doing 50 or 20 reads per second. You can set alarms if you are outside of the range to react to this. And there are scripts ready to use that can run in Lambda function themselves, that if you use too little or too much, the Lambda function will start and do a reprovisioning of the table. So you can change multiple times per day the throughput of your table. So you start with 100, you see you're not using all the 100, the Lambda function triggers, the code is already available on GitHub, and it will reduce the throughput to 50 per second, and then if you don't use it to 25, then if you start using it, it will grow. And you can manage small peaks, because now we give this possibility to DynamoDB users. So currently, you need to take this open source software, one of which I think is written by a customer from Germany, and it's available on GitHub. Other than that, this is something that has been asked for a lot, so it's something that we're thinking if we can improve it. Another thing that was asked a lot on DynamoDB was expiring data, because if you use DynamoDB for sessions, you don't want to keep all the data forever, and maybe you want to delete the data and you have to pay for the deletion. So we added this feature last week, so now you have auto expiring. This is something else that has been asked for, so our attention is also there. So work around, use the scripts, and something we're thinking of.
I would catch up on and ask you a question about the scripts, because maybe it changed, but you can just scale down at NLB 4 times a day, or did it change?
I think it changed, and now it's more flexible.
Okay.
I don't have on top of my head the final, but we increased the number to be more flexible, so now auto-scaling using these scripts, it's much more powerful.
Okay, cool. And originally I wanted to ask, maybe if you don't have a fancy DynamoDB, but relational database and connection pooling, how you mentioned that the container spins up and the container lives longer than the function invocation, maybe?
If you have a database that manages a connection like MySQL or relational databases normally do, there's no connection pooling like in enterprise frameworks like Java Enterprise, but what you can do, you can create a connection before the code of the function. So if you remember the code that we saw at the very beginning, let's say that this function, the code was actually here on Atom. So this is the function that maybe is reading or writing from a database. You can create here some initialization function that will create the connection to the database.
But this would be a bottleneck then.
So this would be one connection, but you can also create a pool here, but you have to manage that. And consider that here you get the resources of a container. So if you use 128 megabytes, you have not a lot of resources. So maybe if you have a fast database, that one connection is already enough to saturate what you can do with this function if you don't give a lot of CPU to this container and you scale using multiple functions in parallel. as we do. Otherwise, you have to manage connection pooling here using libraries that do that, for example. The important thing is never open the connection and close the connection inside the function. Otherwise, of course, the overhead would be ridiculous to the database.
Okay.
So this is something that I would suggest. We've seen lots of customers doing that. You need to put some boilerplate code here, but it's not so difficult to manage. So one question in the back.
I want to use Lambda for real-time bidding. So and I need to respond in 50 milliseconds. What expectations can I have on provisioning and reuse of containers? And also, in case I'm using JVM, reuse of the previous JVM, so cold and warm JVMs?
So the question is, let's say, on the first invocation to see what is the impact. So for normal invocation, you can go much lower than 1 millisecond or a few milliseconds. If you have the first invocation, there you have some time. It depends on the platform you're using. Java is slower because starting the JVM, you can imagine, is slower. The VPC access currently can slow down things a little bit. It's something we're working on, but currently VPC access requires some networking that takes a little bit more time. So if you always need to be below 15 milliseconds, it will be really hard to do that. You can keep a container warm by scheduling a function. For example, you can create a recurring invocation. You can do that using CloudWatch events, and every 5 minutes do an invocation with a sort of standard ping syntax that can be intercepted by your function that terminates immediately. So the cost will be 0 if you do the math. And this keeps the container warm, but still you can have a few initial first invocations. So for the first invocation, Java is slower. The size of the function is impacting the performance. We have customers that work to have functions very small for this reason, because especially if you come from the Java world, you tend to create very large jars, because with Java, if you come from the enterprise, you have 1 jar for logging, 1 jar for doing something else, and then you have a lot of code that you don't use, but it's part of the function. I've seen customers that rethink this approach and start to sometimes rebuild some libraries to be smaller to reduce this impact. Like dates, a lot of people is using huge libraries for managing dates, and then they maybe just need to do the difference between 2 dates, and they don't need to use everything else. So sometimes it can be faster to rebuild this functionality. So if the real answer is, if you always need to be below 15 milliseconds, you can't do that. If you accept a very few of those, so you're talking about maybe a 95, 99 percentile below 15 milliseconds, then it's something that you can start to work on optimizing your code. Other than that, the first invocation is something we are continuously updating to be smaller and smaller. So people that maybe use the platform will have noticed that we are reducing that and optimizing that for, and we're working on that for the future. Okay, seems that we don't have any other questions, but if a good night of sleep will bring more questions, just remember Danilo P, very boring, on Twitter, GitHub, and at Amazon.com.